we will do some more sums based on cells which are connected in series and parallel. First you take down this question. 3 cells of EMF, three cells of EMF, 2 volt, 1.8 volt and 1.5 volt are connected in series. Their internal resistances are .05 ohm, 0.05 ohm, 0.7 ohm, 0.7 ohm and 1 ohm respectively. 1 ohm respectively. If the battery is connected to an external resistor of 4 ohm, an external resistor of 4 ohm, via a very low resistance ammeter, what would be the reading in the ammeter? Also, the second question says, if the 3 cells above were joined in parallel, if the 3 cells in the above were joined in parallel, find the current through the 4 ohm external resistor. First, I will give you the diagram how these cells are connected in series. We have 3 cells. They are connected like this. 3 cells in series, connected in series with an external resistor 4 ohm. This is 2 volt, 0.05 ohm, 0.05 ohm. The other battery is 1.8 volt, 1.8 volt and its internal resistance is 0.7 ohm. This is 1 ohm with 1.5 volt EMF. The first question is, if the battery is connected to an external resistance of 4 ohm via an ammeter. So I'll show you that ammeter also over here. ammeter via an ammeter. What is the reading in the ammeter? That means you need to find out what is the current. So current will be flowing I. So you need to find out what is the current I. The ammeter will read the current which is flowing through the network. We know the reading of ammeter is nothing but the current I. So we need to find out the current I, which will be equivalent to equivalent EMF divided by R equivalent. The equivalent resistance will be sum of all the resistances because they are connected in series. Similarly, E equivalent is the sum of all the EMFs of the cells. So E equivalent is 2 plus 1.8 plus 1.5, which is equal to 0.93 amps. Sorry, 0.93 volts. Oh, sorry, this is not 0.93. So you need to add, so it will come to 5.3 volts. Eight plus 5 is 13. So 1 is the carry over. 1, 2, 3, 4, 5. So 5.3 volt. Then you need to find out what is R equivalent. R equivalent is the sum of all the resistances, that is 0.05 plus 1.8 plus 1.5 plus 4, which is equal to 5.75. Ohm. Now current I is E equivalent by R equivalent, or the ammeter reading is 5.3 divided by 5.75 equal to 0.93 amps. This is the answer for the first question, that is when all the EMFs are connected in series, what is the reading of ammeter. The next question is, if the three cells and the above were joined in parallel, find the current through 4 ohm external resistor. Now we are connecting all of them in parallel. Like this. To an external resistor. Like we have this is like 2 volt, 0.05 ohm, 1.8 volt, internal resistance is 0.7 ohm, (1.5 volt), 1 ohm. This is 4 ohm, and we need to find out what is the current through 4 ohm resistor. Now the cells are connected in parallel. First let us find out what is the effect of 3 EMFs connected in parallel. We know their equivalent internal resistance can be calculated as, first we will find out the equivalent of these 3 connected in parallel. Then we can easily find out what is the current. Equivalent internal resistance can be calculated as we know this 1 by R equivalent so let me take this as R1, R2, R3. These are the internal resistance. So I can write as 1 by R1 plus 1 by R2 plus 1 by R3. 1 by 0.05 plus 1 by 0.7 plus 1 by 1. Do the calculation, you will get R equivalent as 0.05. First calculate 1 by R equivalent, then you will get R equivalent as 0.045 ohm. Now let me take this as E1, E2, E3. We know when the EMFs are connected in parallel, E equivalent, this we have learnt when we learnt the theory, E equivalent by R equivalent as equal to E1 by R, E1 by R1 plus E2 by R2 plus E3 by R3. We know the value of R equivalent. E equivalent divided by 0.045 equal to E1, that is 2, divided by 0.05 plus E2 is 1.8 divided by 0.7 plus E3 is 1.5 divided by 1. Now this we will get it as E equivalent equal to 2 by 0.05 is 40 plus 2.57 plus 1.5 multiplied by R equivalent 0.045. With this, the E equivalent becomes 1.9 volt. Now whole of all three EMFs connected in parallel can be replaced by one equivalent EMF in series with its equivalent internal resistance and also 4 ohm. This is I. This is equivalent or equivalent. Therefore, I is equal to E equivalent divided by 4 plus R equivalent. 4 is this external resistance. Total EMF divided by total resistance. It's equal to 1.98 divided by 4 plus 0.045. 0.045 0.49 amps. When the EMFs are connected in parallel, the current through the external resistance is given by 0.49 amps. When they are connected in series, we got the current through the series combination as 0.93 amps, but now it is 0.49 amps.